Researchers from the University of Surrey have revealed a new method that enables common laboratory scanning electron microscopes to see graphene growing over a microchip surface in real time. This discovery, published in the journal ACS Applied Nanomaterials, could create a path to control the growth of graphene in production factories and lead to the reliable production of graphene layers. The new technique not only produces graphene sheets reliably but also allows to use fast-acting catalysts that reduce growth times from several hours to only a few minutes. With the use of video imaging, the team from Surrey's Advanced Technology Institute ATI have shown graphene growing over an ion catalyst using a silicon nitride membrane produced within a silicon chip. The membrane is only a few tens of nanometers thin, and heating and cooling can be rapidly controlled by means of modulating an electrical signal that is sent to the ion layer. This acts both as a catalyst and as an electrical resistor to supply the heat. The imaging uses Fermi level contrast to visualize doping levels of graphene. This contrast mechanism can be used to identify the point of electrical contact between neighboring graphene flakes. This imaging reveals also that physical contact alone between the flakes is not sufficient to form electronic contact, which suggests additional bonding is required before electrons are able to jump from flake to flake. The researcher says that graphene, the wonder material of the 21st century, has had much written about its unique and remarkable properties over the last decade. It will be widely used if it can be handled expertly and placed easily in applications. To do this, there need to be routes of observing graphene and precisely placing it on devices. In the research paper, one such route, using a standard electron microscope found in most well-resourced laboratories, is exemplified. The researchers hope this work will encourage many more applications and discoveries of graphene for practical use. They believe it is a significant step closer to mass commercialization and production of graphene for electronic devices.